Okay everyone, so in this lesson we're going to be finding angles using trigonometry, and this is going to be only in right angle triangles. So here's our first example, and we've got a triangle here, and we can see that we've got a side length of 7 meters, a side length of 12 meters, and then the angle down here is labelled as theta. And remember, theta is just a Greek letter. It's just like putting x. It's just basically to show that we don't know what that is. Now we're going to use the same steps that we used when we were finding side lengths with trigonometry. We first decide on the ratio triangle that we're going to use, the sine ratio, the cosine ratio, or the tangent ratio. We're then going to cover the thing that we need to find in the ratio and calculate our answer. So we're first going to write SOHCAHTOA in the top corner of our work, and we're going to use this as a checklist to decide what ratio we're going to use to decide what we're doing for step 1. So first I'm going to look at what I want to find in this question. I want to find the angle. So I'm going to tick off S, C and T, sine theta, cos theta, tan theta. Then I'm going to look at the things I've been given. So I've been given the hypotenuse, I've been given this longest side length opposite the right angle. So I'm going to tick off H in my SOHCAHTOA triangles. And then I've also been given this length over here, which is opposite the angle, so I've been given the opposite. So I'm going to tick off the O's. Great, so now I can see that I'm going to use the sine ratio, okay, because it's got all 3 ticked off. Now, in this lesson, we want to find the angles. So we're going to be covering up the sine part of the formula triangle. So what this means is that sine theta, so sine of this angle, is equal to the opposite over the hypotenuse, the 7 over 12. So you might type that into your calculator and say, okay, well, the answer to this question is 0.58333 recurring. And you might round that to 0.58, because that is what 7 divided by 12 is. It's 0.58333. But that is not the answer. 0.58333 is actually what's equal to sine theta, not just theta by itself. Now, to get theta, the angle, by itself, we have to use a special button on our calculators. So yeah, this is not the correct answer. 7 over 12 is not the 0.58333, is not what this angle is equal to. This is what sine theta is equal to. So to get just theta, we're going to use a special button on the calculator. So your calculator should look something like this. And you're going to press the shift button, and then you're going to press sine. And you'll see just above the sine button it says sine and then a little power to the -1. It looks like this. So you're going to press sine to the -1, and then you're going to type 7 over 12. Okay, so this is what you're going to type into your calculator, because 7 over 12 by itself, 0.583, is equal to sine theta. It's not equal to theta. It's not equal to the angle. So we want to find the angle. So we have to use this special button. And this is called the inverse sine. Okay. So we're going to do inverse sine of 7 over 12. And that gives us just the angle. And that should give you, when rounded to 3 significant figures, 35.7 degrees. We'll do another example. So here's example 2. I've been given a right angled triangle, and I've been given side lengths of 12 centimeters and 7 centimeters, and I want to find this angle here, x. So my first step is to decide on the ratio triangle. So using SOHCAHTOA in the top corner, I want to find my angle, so I tick off my SCT. I've been given the adjacent. Okay, this is the adjacent because it's running through the angle, it's next to the angle, but it's obviously not the hypotenuse because that's the longest side down here. So I'm going to tick off the A's. And I've also been given the opposite, okay, opposite the angle, so I'm going to tick off the O's. So, my little tick didn't come off here, but I will be using the tangent ratio, okay, because I've got my tan, I want my angle, I've got my opposite and my adjacent. And I'm going to be, oh there it is, in the wrong order. And then I'm going to be covering up tan because I want to find the angle. Remember, you cover up the thing you want to find. So that means tan theta, or tan x, is equal to the opposite over the adjacent. So 7 over 12. Okay, 7 over 12 again. And again, 7 over 12 equals 0.583333, but that's not the correct answer. That isn't what my angle x, or theta, is. Okay, that is what 7 over 12 is equal to. So we need to go to the special button on our calculator to get just the angle by itself. So on my calculator, this time, I'm not going to press shift and sine because I don't need to do this inverse of sine. I need to do the inverse of tan. So I'm going to press shift and tan. Oops. So I would be pressing shift and tan, and then this would come up. Okay. And then I'm going to type in 7 over 12. Okay. But the inverse tan of 7 over 12 is going to give me this angle here. So 7 over 12. And then I get my answer. My value of my angle is 30.3 to 3 degrees to 3 significant figures. Here are some practice questions for you to pause the video now and have a go at, and then you're going to mark them afterwards. So pause the video now and have a go at these questions: A, B, C, D, E, and F. Okay, so you should have had a go at these 6 questions now. So I'm just going to go through what ratio you should have used to solve, and then what the answer should have been. So for this first one, I can see I've got the hypotenuse and I've got the adjacent. So I'm using the cosine ratio, and my angle ends up being 45.1 degrees, rounded to 3 significant figures. For part B, I've been given my hypotenuse and I've been given the opposite. So that means I end up using the sine ratio. And here my angle turns out to be 44.9 degrees to 3 significant figures. For my third one, I've been given my adjacent and my opposite. So that's the tangent ratio. And your angle C turns out to be 50.7 degrees to 3 significant figures. For part D, I've been given my hypotenuse and I've been given my adjacent, so this is the cosine ratio, and the cosine ratio gives me a value of D equals 35.1 degrees. This next question was actually a bit of a trick question. I didn't give you any side lengths, so you actually can't use trigonometry to solve this, but you'll notice that you've got 90 degrees, you've got 71 degrees, and all you need to do is find this other angle in the triangle. So we can use the rule that angles in a triangle sum to 180 degrees. And when we use that rule, we get 19 degrees as our answer. And our last question, I'm looking to find angle F. I've been given my hypotenuse and my opposite, and that means I'm using the sine ratio, and then these give me a value of F equals 54.9 degrees to 3 significant figures. Here is a challenge question that I want you to have a go at. So we've got triangle ABC shown here, and you can see that I've given you a side length and I've given you an angle here. And I want you to pause the video in a moment and have a go at finding the perimeter of the triangle ABC and the area of the triangle ABC. Pause the video now and have a go. If you feel like you have absolutely no idea what to do, maybe just listen to the next bit so that you can get a hint of what to do. So one starting point is that if we want to find the perimeter of this triangle, well, that means we need to know all of the sides, right? We need to know all 3 sides so that we can add them up and get the perimeter. Now, I only know one side, so it's going to be quite tricky to do that, but I do have this angle here. And I know that in trigonometry, I can find side lengths using angles and other side lengths, okay, in right angled triangles. So if I first wanted to find this hypotenuse here, well, if I want to find the hypotenuse, I've been given the adjacent and I've got my angle here. So the hypotenuse, the adjacent and the angle means I should use the cosine ratio. And when I use the cosine ratio, I find out that the hypotenuse is 18.0 centimetres to 3 significant figures. So I'm a little bit closer to finding the perimeter because I know 2 of the sides and I just need this one down here. Now at this stage you could use trigonometry again because you've got the adjacent, you've got your angle, and you want to find your opposite. So you could go ahead and use a trigonometric ratio to find the opposite here. But because we're dealing with a right angled triangle, you could also use another rule. You could use Pythagoras' theorem. You could use a squared plus b squared equals c squared. I decided to use trigonometry because we're doing a lesson on trigonometry. And so I would have used the tangent ratio because I've got the adjacent and I want the opposite. And this means that the length BC over here is 8.15 centimetres to 3 significant figures. So now I know all 3 sides, I can answer my 2 questions about the perimeter and the area. To find the perimeter, I just add all these 3 sides up, and that gives me 42.15 centimetres. To find the area of the triangle, I need to do the base multiplied by the height, all divided by 2, and that gives me 65.2 centimetres squared.